Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're looking at lesson 4 from chapter 6, which is looking at slope-intercept form of the equation for a linear function. So if you guys remember back to chapter 5, we had basically a whole lesson talking about the graphs, table values, and our ordered pairs from looking at the situation of car rental costs. And so in that lesson, we'd also given you an equation which was C is equal to 0.2D plus 60, where C represented your cost and D represented the distance driven by that rental car. So what we can do is we can break down this equation into the different parts, just like what we did in our lesson in chapter 5. So here, our first variable here is the letter C. This one here is your dependent variable. This one here usually belongs on your y-axis, and it depends on your independent value. So it depends on the other variable. So how much you're going to get charged depends on how much you drive that car. So this one here is your independent variable. So then the number that's connected to the independent variable is what we call your rate of change or your slope. So your rate of change or the slope. And then this number that's tacked off to the side here, we have labeled as our initial amount. And this initial amount is also where it intersects at your y-axis. So we call this your y-intercept. So an equation in this form where we have our dependent variable and our slope connected to that independent variable, and then we have our initial amount, this here is essentially what we call an equation in slope-intercept form. So when we're in this form, we can easily see our slope of the graph and where it starts, or that y-intercept. So we have a little general equation for this, and that's y is equal to mx plus b, where b is your slope or your rate of change, where m is your rate of change or your slope, and b is that y-intercept. And then we typically always just have our x and y variables, and depending on the type of situation, we might actually have some different letters to represent that. So now we're going to look at example number 2 from your notes, where we're going to create an equation in slope-intercept form, given its graph. So here we're going to write an equation to describe the function that is shown in this graph here below. And then what we're going to do is we're going to verify our equation. So when we're writing an equation to describe a linear function, we can always write it in the way y is equal to mx plus b. And then when we're writing these equations, we want to have a number for our m value and one for our b value. Otherwise, we'll just leave x and y as they are. So our first step here is we're going to be finding that slope or your rate of change. And there's two different ways that we can do this. We can either use our rate of change equation, or we can also just look at the graph and see how much it goes up and to the right, and using that rise over run. So what you want to do is you want to find maybe a nice point on your graph. So maybe you want to use this y-intercept here. So you have it's 0 and -3. Then our next really nice point might be here. We have x equal to 1 and y is equal to -1. So if you guys look here, we're moving 1 to the right and up 2. So we're rising 2 and running 1. So we're going to have a slope of 2 over 1. Which is simply just 2. If you guys were going down, so you would not be rising, you'd be dropping, you'd want to have a negative value, and you always look at, in terms of that run, is always going from left to right. So really depending on whether or not your slope is positive or negative, depends on this rise, if it's going up or if it's going down. So in this case here, we have your slope is equal to positive 2. So then what we can do next is we need to find that y-intercept, which is that b value. And in this case here, we're given it on the graph, which makes our life very easy because we just have to look at that value there, which in this case here is -3. So your coordinate here is 0 and -3. So this y-coordinate here is your b value. So b is equal to -3. So then plugging this into your equation, we have y is equal to m, which is 2, x, and then we have plus -3, which we can simplify to 2x minus 3, because a positive times a negative makes a negative. And then, as I said before, we want to make sure we leave those two x and y variables in there, so that way we have an equation that we can use to find any coordinates or any missing point on that graph that we might want to use. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. Thank you guys for watching.